Okay, that's where we left. Okay. So let's pick up where we were. And this probably will go into Friday as well, but at least I'll make it complete. Also, what I'm going to do is another instant center thing over here later. This will be the last thing I do where I look at the distances, but that's the last thing I'm going to do. So let's see. Let's do this. And since I can do this, what I will do is see if it'll allow me to select all that and move it all over here. Then I can come back to that, but I'll use this space for this right here. So let's start with the velocity. If we go in, we'll start with this one first. Then I think I'm going to do that one second, this one third, and that one fourth. So the first thing is to recognize this velocity is 0, and it's hard to see it, but if you zoom in, that right there is D. So that means this is 0. So I'll do it kind of like that. That way, this equation I only have to write that, and this equation I only have to write that. So what I'll do is do each one, and then I'll put a box around it and move it out of the way. So I'm trying to think whether I should move these out of the way. And I'll go ahead and do that. And then just say unknowns. And so that way I'll get this spot right here. Okay, so the velocity of B is equal to omega AB, which is this. Okay, hang on. This should be omega AB represented as a vector R, and the same subscripts occur here. And so now I can make use of all these information right here to find each of those vectors. So first of all, like we talked about before, this is a positive omega and a positive alpha. So it seems as though I've chosen both of these to be positive. And so the matrix JK, and then 0, 0, and 5. Okay, 5, because that's the first one. The second one, draw a vector from A that points to B. A to B is just that value. So it's basically 4, 4, nothing. So really, well, I'm trying to think. It looks like I'm not going to have a K component, because if I get rid of this row and that column and take the determinant of this, I'm going to get a 0. So I'm only going to have an I component, which will be 0, 5, 4, 0. And I'm going to have a J component, which looks the same, because this and that are the same thing. 0, 4, 5, 0, And so what I'm going to get is that times that minus that times that. So I'm get a minus 20I plus 20J, and that's going to be the velocity of B. Now, does that make sense? Okay, so my picture is here. I'm going to copy it, put it right here. And, okay, so if I draw this vector on this, I go up 20, then back to the left 20, and it turns out that that vector is, in fact, perpendicular here. Now, the other thing I can do to check that, and this one's kind of, here, I'll go back and do that later. My dot product thing that we talked about one time, you know, A, okay, so if you have any vector A cross B, because A and B make their own plane, you cross it, this vector is perpendicular to both, so A dot C equals 0, and B dot C is equal to 0, or C dot B. So this times that plus this value times that value doesn't tell you anything. But this one times that plus this one times that does tell you something. That just tells you that, yeah, in fact, this is perpendicular to that one, and it's perpendicular to that one. So we're all good there. And so now I'm going to go off. So let's see. How should I do this? I'll do this. So here's my first one. Tell you what, let's do this, because then I might be able to save a little space here. So there's my first one. Now what I'll do, I'll get it down out of the way, and then I'll do the second one right here. And the second one that I was going to do was this one. So the velocity of C is equal to the velocity of C relative to this D right here, which that's nothing. And so in other words, what I'm saying, velocity of D is equal to 0. So I'm not even going to write it. And so what you get, the velocity of C is equal to omega CD cross R CD. So I got to find this R. Well, first of all, let me write this. JK 0, 0. I do not know this omega. So I'm going to assume it to be positive. And then I'm going to come up with the vector that starts at D and points to C. Okay. It goes from D to C. Okay, so looks like I go to the right two. Actually, this is to scale. Go right 2 and up 4. Difference between these two is 2. Difference of those two is 4. So let's see, where can I put that? Oh, here. Well, get rid of this. So, okay. So I can just put it over here. It goes to the right 2 and up 4. Let's just make sure that. Goes to the right 2 and it goes up 4. So I think I'm okay. Now I've sort of invaded the area below me, but I can just shove it down a little bit. Can't do that on the board. Okay, so velocity of C, oh, here, I'll do it this way. Let's see, 0, 4, omega CD 0, and minus J, and 0, omega CD 2, and 0. So that times that's one thing, but if this times this minus, that would be minus 4 omega CD I. That's a minus, but so is that. So I get a plus 2 omega CD J. Immediately I do a check. That times that plus this times that shows me that they are, this is perpendicular. VC dot RCD is equal to 0, so they are perpendicular. So that's kind of a check along the way. At this point, I can't really do anything more than that because I don't know omega CD, and that's the point. I'll have to find it. So let me do this. Oop, that's not the one I wanted to hit. That's the one I wanted to hit. I'm going to do this one. And now I'm going to grab both these things and move them kind of out of the way there. Then I promised I was going to do this one third. I'm going to do that one third. Okay, so C and B. Okay, velocity of C equals velocity of C relative to B plus the velocity of B. The funny thing here is I've got an equation for this, and I have an equation for that one too, off of the last one. But I'm just going to carry them for a minute. Maybe I should bring a stick in here to, I mean, this used to have bolts on it. I don't know why you would put a hinge on this. If I put my legs under it, I can only go so far till it either breaks my legs or, okay. So I'm going to focus mostly on this because that I'm just going to draw from down here, and this one I'm going to draw from down there. So what I'll do is just move the VC over and do omega CB, BC, it doesn't matter, R, C to B, plus velocity of B. And then CB, I don't know the rotation of CB. Actually, I do, but I'm not supposed to. I do know it over here. But that's the whole point, is I'll be able to check all my numbers against the instant center. So that's why I wanted to do a complete problem from the beginning to end. So I, J, K, it's planar rotation, so there's nothing there. And now I need to know a vector that starts at B and goes to C. Looks like it goes down 2 and to the right 6. Down 2 to the right 6. I hope that's correct, because I think these were 2 by 2s. Okay, plus velocity of B, velocity of C equals 2. Okay, so I'm just going to focus on this. Oops. You know, I didn't do one thing I should have done. And I'll do it on this one, because this one's more appropriate to think that way. Okay, so I'm going to do the multiplications. They take that, put it down here. 0 omega CB, 6, 0 minus J. And what I'll do is take this matrix, or 0 omega CB minus 2, 0. And I'll go ahead and say VB and VC. And then I get that minus the other. So I get minus 6 omega CB. That's not a vector. I. That is plus. This is minus. But then there's another minus and then another minus. So you get minus 2 omega CB J. Okay. Now, in my mind, I'm ignoring this and this right now. I'm focusing only on this. And what you find out is this times that plus that times that will show you that those two, the vector that I get here, that velocity, whoops, I have to hit the escape key sometimes. I don't know why it does that. So the velocity of C relative to B is in fact perpendicular. If I dot it with the RCB, I'm going to get 0, which means that's a check for me. Here's the other check. Okay, so if I grab this picture, do a copy, and this is kind of an interesting way to think because it actually is the way you're supposed to think about these things. If you look at this thing, you want to know the velocity of B relative to C. That's what I got right here. Oh, I'm sorry, C relative to B. C relative to B. So in your mind, what you do, you put a pin right here. Your pin is, I'm stuck right here at B. And if I see a positive rotation, meaning I see that velocity should poke up this way and be perpendicular to this. Do I see that? No, I don't. Let me make sure here. So something is amiss here. So the other choice is it could be that. And that looks like that's what I've got here. Now, if you do a cross product, a vector this, if I do this, say A cross B, and if I do a minus A cross B, I get a different vector, C, versus this one. Both these vectors are perpendicular. They're all perpendicular. So that doesn't get you the actual proof, but let's see what have I done wrong here, or have I done something wrong? Okay. Only thing I can think of is C, start at B and draw to C. Go positive. Ooh, wait. Okay, start at B and I draw to C. I start at B. Oh, I go to the right 6 and I go down. Oops, that's supposed to be 6 and this is supposed to be minus 2. Does that make sense? Did I goof that before? Looks like I goofed that. Good thing we're spanning this over multiple lectures. So the X component is 6 and the Y component is minus 2. I got going so fast I flipped those. That means this is the minus 2 and this is the 6. Okay, so I think what we're going to get is 6 and then 2. Yeah. So in fact now, so that's a way to check it too. This term should be thought of as find yourself the base point. B here is being the base point. Pin the system there is what I did. Put on a positive omega. The velocity should go this way. If this link doesn't exist, this one and this one and this, and it is just a link rotating like that, it's got to be this way, meaning positive this and positive that. So in fact, yeah. And the other question is, did I do that correct? As far as let me double check. So B, drawing to B, going to C means I go to the right 6, and that, yeah, go down 2. So that's, I think we're good there. So if that makes sense, I'm going to erase all this, and that there's no reason to keep that in here. I just delete it all. Now, here's the funny thing. Okay. Out of this last equation, I've got that one. And out of this one, I've got that one. So now I'm going to do that and combine all these down and write all this out and see how awful it is. And of course, I can just do this and do a copy. Just do a copy instead of rewriting it. This equals to this plus this one. Wait a minute. I'm just making sure you get the right one. Copy. Okay, let's make sure I copied the right one. VC and VB. Okay. Now, if you stare at this thing long enough, you realize you have an equation for I and an equation for J. And you also have two unknowns. You have this and that. So what I'm going to do is I'm going to identify the I's. And then I'm going to identify the J's. And then I'm just going to write the equation. Okay, so for I minus 4 omega CD equals to 2 omega CB minus 20. And up here I got 2 omega CD is equal to 6 omega CB plus 20. If I want to write that in a matrix form, I can move this to the other side and this to the other side. And what I can get is an equation that looks like this. Minus, and put it equals here, and it equals minus 20. Okay, then I can go ahead and put it in a matrix form. Minus 4, 2, minus 2, minus 6, and omega CD and omega CB. And it's got it equal to minus 20 and 20. Okay. Do I have to double click that? I don't know. I may have brought the computer to its knees. I don't know. Oh, yeah. You just have to single click it. Go away with 2 of them, and I'm left with 1. Okay, so I'll take the matrix and put it in there. K is equal to minus 4 minus 2, 2 minus 6. We'll get that out of it. And then the right hand side is minus 20 and a 20. And then I do inverse of K. Was it a capital K? No, it was a smaller case times the right hand side. 7143. 5.7143, I think. And the other one, minus 1.4286. Or technically, so omega CD rotates that way, omega CB rotates that way. Let's now, I've got enough information to do a check now, but unfortunately I got to dig around. Okay, there's my omega BC now. Let's take a look at this. There's BC. It's rotating. Okay, remember, this is positive from a vector standpoint, but this is rotating the opposite way. So I got a minus 1.4284 and minus 1.4286. That's good enough. And then the other one's 5.71. Okay. Okay, let's see. Uh-oh. Uh-oh. That's CE. It's CE. Where's the other one? Okay, wait a minute. Did I ever really move? Oh, wait a minute. That's BC. What's the other one? Okay, what did I just find? Oh, I found the one. You know what? I never really found that, did I? Okay, so let me do that real quick. So the velocity here at this point is that. The distance is that. So velocity of C is equal to omega R, meaning that this is 25.55 equals to omega of this length, which is CD, times R of 4.4. Yeah, I didn't find it at all. 4.47214, or omega CD is equal to, I guess I didn't need to from the way I had asked myself the question. 25.55 divided by 4.47214, 5.7131. 5.7131. Now, if you look at this thing, and it is pinned there, in order to get the velocity going in that direction, it has to rotate that way, which is positive. So 5.7131. 5.7143. So that's close enough. So now I've got those two. Now there's one last equation. And this has kind of gotten itself out of control. Okay, so the last one is C and E. Now, what I really should do, here, let me do this, because I'm going to probably use these. I'm going to go ahead and box this one, because that's one of the equations. And now I'm kind of out of control as far as my space is going. So how do I get space here? Because I've sort of bled down the page. Well, C and E. Let me just do it down here. Velocity of C is equal to velocity of C relative to E plus the velocity of E. Is that what I've got? Now, shoot. What I could do, here's what I'll do. I'll do this. Just go up here. Yeah. I quit. I'm going to go ahead and get all this. I'm going to do something radical. X. And it's gone. And then I'm going to go down here. And let's see if it just reappears. Oh. Man, it reappears in the wrong place here. Put a little pin. Drop it right there. And that will appear right here. So I'm going to use it as a guide later. And then I'll have myself a little space that I can work right up in here with this one. Okay, let's see. And, okay. All right. So I'll work off of that. So, thing about velocity of c is I'll know it from over here, but I'm not going to find it quite yet. And then what I'm going to do, that actually is supposed to be e. I know that velocity e has to go to the right or left. So eventually I'm going to put in just velocity of e times I, because it has to go to the right or left because that's where it's at. But I'm not going to worry about that right now. I'm just going to focus on this one, which actually is omega CE cross R C to E plus that. And I don't know the CE yet, but I can do C to E. Looks like I go to the right 6 and down 4. So I go to the right 6 and down 4. And this omega CE, this 0 and this 0 plus. I'm carrying it, but I'm going to ignore it for a while. Okay, so I've got I, I've got 0, omega CE, minus 4, 0, minus J, and we get 0 and 6, omega CE, and 0 plus BE I. And I'm still ignoring that. So what I'll get here is 4 omega CE I. That and that plus this is minus another minus gets you back 6 omega CE J plus velocity of E J. I'm going to do the same thing as far as the logic here. Okay, so this is pin E and watch C. So here's what's funny, okay? So this is really weird. Gonna pin E this time. Okay, it is not pinned. It's moving to the left or right, but I'm gonna act as though I'm pinning it, and the rotation is this way. Okay, so already I see a problem. First of all, let's check. Yes, this times that plus this times that. It's true. That's 0. But I'm a little bit discouraged here in the sense that I'm pinning E and I'm looking at C. And if I rotate, whoop, wait a minute. Yeah, that's a positive. So I should actually see something with a minus and a minus here. Why do I not see that? Okay, let's see if I can figure this one out. Did I group this one? Okay. Yeah. Because I'm supposed to take E, draw a vector from E pointing to C. The vector from E pointing to C, oh, go away, goes positive. So the vector R pointing to C, originating from E, goes back to the left 6, I, and then up 4, J. Is that right? So yet again, I made a mistake. Minus 6 and 4. But yet again, I caught the mistake because this logic right here, even though that dot product was correct, in fact, okay, hang on. Plus, even though the dot product was correct, both this vector and that vector are both perpendicular to this. So you got to have that extra bit of logic, and that is you're pinning this point fixed, and then you're rotating about it, and that'll tell you whether or not you've got the vector in the right direction. So if I am rotating that way, it has to go that way. So again, I goofed, and again, I caught it. And this goes back to my point. The best engineers are not necessarily the ones that work the problem all the way through to right the first time. The best engineers are the ones that know how to fix their problems as they go along. So, so VC equals to VC. So as you learn the material, that's one thing that really everybody kind of, I mean, I'm not saying I'm super successful at it, but I'm saying there's a lot of failures in that concept in the classroom because you're always taught work the problem, get the answer in the back of the book, get your grade, and move on. But there's an extra part to the problem that might come along as you get in practice. I don't know. I really don't know. Okay. So I got a little bit. So this side of the equation is all happy. This side, I have to get from here. So if you notice, I didn't act, I mean, I found omega BC and CD here, but I didn't really go back and find the velocity of C. Now, one of the things I could do, this is the easiest place to get it, right here. Take omega CD. Okay, so let's see, how can I go do that? What would be the simplest way? I guess I could go right here and say, here, I know what I'll do. I'll do this. Take that whole equation, copy it, head down here, and zoom in, and then take, okay, wait, which one? C, I gotta take this number and stick it right here, and I gotta do it again and stick it right there. So velocity of C is equal to minus 4 times 5.7143 I plus 2 times the same 5.7143 J. I don't know. I guess by the time I pull out my phone and do that other thing, I could just multiply it. Here we go. 2 times 5.7143, 11.429. And this one's got to be about 22. Here, I'll even do, okay, here we go. Times another 2, because that's what that one is. 22.857. 22.57. And so then I'll use I'm going to use this again. And this time, I'm just going to do a copy. Go back over, find where that was at. Kind of stick it right here. Man, I have really cramped this thing up. Here. And copy, and I don't know how I'm going to do that, so I'm just going to say that. Now, what I've got is an actual equation with 2 unknowns, but I have an I equation and I have a J equation. And the I equation, you know, here's what I'll do. That should have an I on it. Let's go back down here and put the, yeah, that should have an, whoa. Yeah. Not that it really matters. I mean, I know there's supposed to be an I there, but, you know, anyway. If I make a mistake, stop me. Okay, okay, we got an I. So I'm going to do the same thing. The greens will be the I's. And then say the blues will be the J's. So I got an extra term in there. And so minus 22.857 equals to 4 omega CE. Hey, I can get that straight out of there. And then 11.429 equals 6 omega CE plus the final velocity of E. So first thing I'm going to do is take the I equation and say omega CE is equal to minus 22.857 divided by 4, which is a number larger than 1. 4, guess what? It's 5.7143. 0.7143. Wow, that seems weird. Okay. I don't know. There might be something wrong there. That is not what I got here. Omega CE. That is not it. So I will have to investigate this as well. But let me run back over here. There's really no reason to complete that out if that's the case. Let me think about that for a minute. Omega before CE. Okay, so there's my problem. Okay, so this is a good time to stop on an error. There's an error somewhere. It's either in the instant center or here. And we got 5 more minutes. Let's just see if we can. Okay. There's something that we did wrong here. One of the things we should look at right off. Well, we did that little look at the terms there. See, we copied that down correctly. And then there's something's making me feel kind of uneasy about this because for the 4, did I get that value correct? Okay, I go back to the left 6. This is 2, 2, and 2, and up 2, 2. So I think we're good there. Now I'm going to go back over here and just see, did I, okay, so I got the same thing here, 25, and then divided by the R is a different R if I had put in the same R. So I'm going to have to track this down, but I don't know if I have time to do that right now. So that's what Friday's for. So yeah, I'm reading something unrelated to anything. So anyway. So I'm leaving it. It's like a movie. It's like a series on TV. You're watching it, and then all of a sudden, right near the end, somebody like falls off a bridge and or something, and they're falling straight to the river, and then the thing quits, and you're like, that person can't die because if they died, there would be no more show left. So, so there you go. I'm leaving on a suspenseful note. Something is terribly wrong. What is it? So if I felt like it, I could print this off as a PDF and then give it. Can you do that? How do you do that? Print. Let's see what happens. I think there's a PDF writer in here. Oh yeah, connect it. Okay, print to PDF. What was it? What would it look like? Oh gosh, it's not going to even fit on a page. Could you even see that? Or is it all fuzzy? No, you can see that. But half of it's hanging off one page, and then half of it's hanging off another page. Then you could tape them together and sit there and work them, you know? What if I should do that? I could send everybody this and say, fix that. Fix that by Friday. Maybe I'll do that. I don't know. That might be fun. Here's your test for Friday. Then people who are not keeping up are like, what? I should do that. I think I'm going to do that. That's funny. I'm thinking of new and innovative